Moving on to the next question, which is asked from the subject transducer in test series 12 for IN, is of 1 mark. It is from the topic resistive transducer, and it's basically fill in the blank or range kind of question. So we'll go through the question. So a strain gauge is mounted in a bridge circuit, which is shown below. So here the variable resistance R4 is 120 ohms at 0 strain. So the value of R4 is 120 ohms when the bridge is balanced or when there is no strain applied, and the new value is 120.63 ohms when the strain is applied of E. So the gauge factor is 2.04. So the strain in the beam at the point when the strain gauge is attached is equal to, so what is the strain in the beam which is causing a change in the R4 resistance of 120.63 ohms. So here this you can see the strain gauge is R3, so is represented as by R3. So initially when the bridge is balanced, that is when there is no strain applied. So when there is no strain is applied, bridge should be balanced, so that means V output should be equal to 0. So in that case the bridge should be balanced means R1 R4 should be equal to R2 R3. That is a balance criteria for any bridge. So here we know that R1 and R2 and R4 all are equal, so we can cancel out, and R4 is equal to 120 ohms when there is no strain applied. So hence R3 is equal to 120 ohms, which is the value of the strain gauge when there is no strain applied. So that is what is being calculated here. So hence R3 is equal to 120 ohms. And now the change in R4 resistance when the strain is applied is 120.63 minus 120, which is delta R, the change in resistance, which is 0.63 ohms when there is a strain is applied. So this should result in change in value of R3 as well to make the bridge balance. So delta R3 is equal to R1 by R2, which is nothing but here R1 by R2, the same balance condition. So if I take R2 to the left hand side, it will be R1 by R2 into R4. Here I am calculating delta R3, so it should be delta R4. So here R1 R2 are equal, so they get cancelled out, and R4 is 0.63, which we have calculated here. So delta R3 should be 0.63 ohms for the bridge to be balanced. So we know that change in resistance, which is delta R3 by R3, is equal to gauge factor into the applied strain. So here we are asked to find what is the strain that which is applied. So strain is equal to delta R3 by R3 into the gauge factor into 1 by gauge factor. So we have calculated delta R3 as 0.63 ohms here, and R3 is 120 ohms into 1 by gauge factor, which is given in the question as 2.04, the gauge factor is. So when we simplify, we get the strain as 2.573. So here the strain is applied is 2.57.